Hello students, today we will be discussing the chapter time and motion. Time and motion. Though time and motion are two different things, but they both are interlinked with each other. Time has become a very integral part of our life. Without time, I mean clock, you can imagine our life. Just imagine if there is no clock, what will happen to our daily work. For example, you will be not able to go to school on time, and you will not be able to wake up early in the morning. Yes or no? Our daily life routine work will be hampered a lot. In old days, when science was not so much developed, our ancestors used to depend on a natural phenomena to track the time. For example, from one sunrise to the next sunrise was considered as a day for them. Okay? That means Monday morning sunrise till the Tuesday morning sunrise was considered a day. Okay? Next, one sunset to the immediate sunrise is considered as a night. For example, Monday evening the sun sets, Tuesday morning the sun rises, that period is considered as a night. Okay? Next, one new moon to the next new moon. From one new moon to the next new moon is considered as a month. Okay? Next, time taken by the earth to complete one revolution around the sun was considered as a year for them. Okay? So as time developed, people started thinking some innovative ideas. Like they thought of inventing some new devices to measure time. Okay? And the study of these devices, to measure time is known as horology. It's known as what? Horology. Okay? And one of the device was sundial. Okay? And basically the sundial is a circular plate. The sundial is basically a circular plate. You can see over here. Okay? Right in the center, there is a triangular metallic plate. And that triangular metallic plate is known as gnomon. That triangular plate is known as what? Gnomon. Okay? And this gnomon should be placed in the north-south direction. Okay? And the shadow of this gnomon tells the time of the day. Okay? And one drawback of this sundial is that it works on the sunlight. If there is no sunlight, it can't say about the time. Okay? And if it is very cloudy also, or it's very rainy day, then also sundial cannot say us the time, because the shadow only tells us the time. Okay? So proper sunlight is needed to know the time. Okay? So the next device that we'll be discussing is water clock. Water clock was used by the Greeks to measure time, and the diagram of the water clock is in your book. So to be true, I am not good in the drawing, so my drawing is so light, so it's better you see the diagram in the book. Okay? So the water clock was discovered to measure time by the Greeks. Okay? And this water clock was mainly invented to measure time during night time. Okay? It was mainly invented to measure time during the night time. Next, rising and falling of a liquid column. Can you see? In the top there is a liquid column, as well as in down there is a liquid column. Okay? And the flow of the liquid column used to say about the time. Third point, regular monitoring. So the rate of flow of water varies with the temperature. Okay? The rate of flow of water varies with the temperature. So sometimes the rate of flow of water will be very high, and sometimes it might be moderate, and sometimes it might be very low also. So regular monitoring of this water clock is very necessary. Okay? The next device that we will be learning is a sand clock, and sand clock is also known as hourglass. Okay? Can you see this figure? You can see the diagram in the book also. Okay? These two are vertical bulbs facing each other, and there is a narrow passage. Okay? Suppose these two are the vertical bulbs. This down bulb I have filled with sand. Okay? Once I fill up the down bulb with sand, I will make it inverted. Okay? Once I make it inverted, the sand that is present in this bulb will flow from the narrow passage to the bulb that is down. Okay. And this flow of sand from this bulb to this bulb is used to measure time. Once it is filled up, again it can be inverted to measure time. Okay? Nowadays this sand clock is used as an ornamental and is used to decorate our home. The next device that we are going to learn is a pendulum clock. You might have seen the pendulum clock where the bob used to swing to and fro. Suppose this is the point from where the bob used to hang. The point from where the bob used to hang is known as the point of suspension. Okay, and this bob is a metallic plate, a round metallic plate. Okay, this bob used to move right and left continuously without a break. The movement of this bob from this point to the end point, this point, again coming back to this point, is known as the time period. Okay, the movement of this bob from one extreme point to the next extreme point, again coming back to this point, is known as what? Time period. Okay, the time period of this pendulum usually depends on the length of the thread. Okay, the length of this thread. Okay, it doesn't depend on the mass of the thread, it usually depends on the length of the thread. And this time period is usually periodic, that means it repeats after a fixed interval of time, so that's why it is known as periodic. Okay, and the movement of the minute hand and the hour hand and the second hand of a pendulum clock depends upon the movement of this mass, that is to and. So finally came the modern day clock, that is the quartz clock, and it was invented on 1927. I have drawn the diagram over here. Okay, then came the atomic clock. An atomic clock uses electronic transmission of time, and the time is being displayed in this ultraviolet region. Okay, in this atomic clock you can also see date also as well as time also. Okay,